Welcome back, everyone, to another episode of Reliability Boombox, proudly brought to you by Reliability Extranet Group of Companies, Reliability Analytics, and Logic Australasia. Today, alongside with Seven. Welcome back again, Seven. Always lovely to see your face.
Thank you very much, sir.
We have Steve Davies, who is actually one of our clients in the Reliability Analytics world. He's going to describe a little bit more, but basically it's been around for a while, managing assets in the mining industry. And we just thought we'd get him on to have a couple of quick questions around asset health and the importance of that. So welcome, Steve.
Thank you.
Thank you. All right, Steve, can you just start with a little bit of what's your role now? You don't have to disclose where you actually work, but just your role and maybe a little bit about your experience.
I'm actually my role is an asset health specialist. I'm a superintendent in one of the large open cut coal mine operations in the Bowen Basin, and I guess I've been in condition monitoring probably last 15 to 20 years, which is a fair while, and I've seen a lot of changes in that time. But in the last probably 10 years, I've spent a lot more time in the reliability maintenance asset type reliability space. So really trying to get our head around what the health of our machines is at any particular point in time. We've historically only been able to see the quality of our machines, or what the machines are telling you there is wrong with them, by looking at the traditional condition monitoring tools like oil analysis, vibration, and just specifically, I guess, what you call physical checks like preventative maintenance, inspections, visual type inspections and things like that. So that's been our fundamentally the only way we could really understand what was going to happen with our components, how long they would last. And so I guess for the last 4 or 5 years, we've been searching for a way of being able to move that reactive type condition monitoring into something that's a bit more predictive. And that's where we sort of had a bit of a reach out and found Seven and the team and started looking at options to be able to look at real-time data and then what those trends look like, to help us predict failures before they happen rather than fix them after they happen. So I guess for those that know what the PF curve looks like, if we can predict failures before they happen, then obviously we reduce the amount of time it takes to repair the machine. We prevent hopefully that catastrophic failure where we not only have to repair the problem, but often have to spend a whole lot of time dragging the machine back to a workshop because it's broken down in the pit. We often lose the core, the main core of the machine, which instead of being maybe a $50,000 or $100,000 repair turns into closer to $1 million. So yeah, that's a bit about my journey. But I've been on this journey for a long time, and I'm starting to now see, some of the round holes lining up with round holes instead of the other way. Hole, I guess.
Yeah, nice. Well, you before we jumped online, I had a little rack on my brain of what questions can I throw at Steve, because we are on a time limit today. You're a busy man, and we appreciate you jumping on. And one of them was just the importance of real-time data. You've kind of sort of half answered that there already, which I really like your explanation of just, understanding the PF curve and trying to get to it before to actually save the costs. So fantastic. I think that's great. And what's probably one of the biggest things you've learnt since being able to capture some real-time data?
For me, being my trade is obviously as a fitter, I've looked at this I guess this challenge for quite a while, and one of the things that has always been thrown at me is that this stuff is really complicated. It's all about computers and logarithms, and it's really hard to do. And I've always believed that to be rubbish, and fundamentally it's because the people that have been trying to do this stuff haven't had the background of where I guess the difference is between the computer people versus the hands-on people. We know how to diagnose a problem, so having that ability to do the diagnosis gives you a much better insight as to what things you need to look for. So if I know what things to look for, other than oil pressure or temperature or the various different things that are going to basically create the problem that I'm seeing, I've sort of found that the computer scientists don't understand that piece. So they've got all this fancy data and they overcomplicate the analysis to a point where it doesn't make sense to anybody. So what we wanted to be able to do is say, how do we find tools that we can put in the hands of the everyday maintainer that says, hey, here's what your trends look like. This is what your data looks like. That confirms your prognosis. So therefore you can go ahead and do your repair in a much faster fashion and hopefully a lot earlier, because we can see that starting to happen. And I think when we started looking at this stuff, we can look at the point where it failed, which is what we've always only been able to do. And then we can say, well, that's what all of the data was telling us when it failed. So if we could go back in time and have a look at when it was normal, then hopefully we could see where that data started to change its patterns and predict that failure, because the data's going to tell us this is what failure looks like, this is what normal looks like. Obviously, there's a point in the middle somewhere where it starts to trend upwards towards the failure. So back to the PF curve, that's sort of halfway through the curve rather than right at the end of it. So, and I've always known that, but I guess, I don't know, for one of people trying to keep their jobs, they've always said to me that's way too complicated. And what I've found since, finding the Sorba platform and the ability to visualize what we're suspecting is the problem, it's actually quite simple. And now the challenge is to convince the people that want to make it complicated that it isn't complicated, and to now teach the people that are doing the diagnosis, hey, before you go out and put all your gauges on and things like that, open up the data trends, have a look at it, and you don't need to do half of that diagnosis. It's right there in front of you. So you can actually identify what the problem is and then just go straight into fixing it, rather than having to spend hours doing diagnostics. Because with the real-time data, we're able to do that diagnostics prior to the fault find, I guess, or as part of the fault find. I don't know. Does that make sense?
Yeah, that makes perfect sense. And Steve, as you know, I'm electrically minded and come from a trade background as well, or craftsman background for the Americans in the room. We always used to have challenges with the engineers that were fresh out of uni, fresh out of training, that didn't have any physical on-hands experience. And it's the same, it's like what you're describing here, where you've got the computer scientists, the data analysis, that are used to looking at all the data and breaking down all the bits and pieces. And they think then they sort of go from a collect everything, and they kind of look at the truck, or just for example, and want to plug in everything, plug in all the sensors, plug in all the bits and pieces, and then spend a lot of time looking at it, figuring out and understanding what's what. Whereas when you get someone from a trade background like yourself, or actually hands-on experience, or someone that's actually even an engineer that's got their hands dirty and got their time to understand mechanically how it functions and where it works, you can focus in a little bit better. So with the real-time data, you're also able to go, well, okay, all this data is coming from, this is the suspension data, this is the engine data, this is this data. Our fault's in the engine, so let's look at the engine data and focus in on that. And you can sort of streamline the process a little bit better, and get that early warning of potential failure, is what we like to sort of phrase it. So yeah, that makes perfect sense, Steve, and I think that's great. I know we are short on time, so I don't want to leave you late for your other meetings and stuff. But is there anything else that you'd like to share about your experience quickly that you found with you since using the platform? And I do say to Seven and others, like I feel like for Seven and I, and possibly where you're at, every time we talk to the guys in HQ, we get blown away by a little bit more that this platform can do and something else. And we're still riding with our training wheels. So yeah, I guess from your point of view, is there anything else that you really appreciate about the platform?
Oh, yeah, look, I think fundamentally, I suppose the thing that I enjoy about the platform is, well, it's a few things. The support is fantastic from Seven and the team in the US and whatnot. But I think the fact that it's something that we're able to jump on, pull the data up that we need in a very short, simple process. It's not difficult. We can then go to our analytical piece, or our fault finding piece, with a lot more accurate information. So we can rule out. Part of being a good troubleshooter is ruling out stuff, not ruling in stuff. And a lot of people don't understand that. So when you've got something that's wrong, typically there's 100 things going on in your head. It says, it could be this, could be that, could be that, could be that, could be that. So if you're able to look at some real-time data and rule out all the things that the data says it's not that, it's not that, it's not that, you end up with a very short, precise list, which you can quickly go after and say, right, it's got to be one of these three things, or one of these two things, or whatever. It allows us to then go straight to the machine and say, I need you to check that. And with our maintenance control team, they can basically then guide the fitter. It goes down to the machine and say, I need you to check these three things. It'll be one of those, just about guarantee it.
Yep.
And we're finding that is actually the case. So, if you've got 30 years of diagnostic experience, typically you can do a lot of that anyway. What we're facing now as an industry is a very, very significant reduction in the amount of ability for people to do that diagnostic analyst and analytical stuff, because typically our industries are moving into more of a let's just replace the part rather than try and figure out what's wrong. So we've got a bunch of, we even call them fitters now. We don't even call them technicians or mechanics or anything like that. And that's pretty much what they can do. So to get a fitter who's only used to taking a piece off and putting it back on, and they just keep doing that until they fix the problem, obviously that's not a great approach. But to get a fitter and say it's that, or that, and this is what I need you to check, we can then guide people with far less experience to the end result, which is what we want to get to. And to me, that's a step change for our business, which I don't think a lot of people really understand. So, with the central group that we've put together, that's part of the core training that I'm giving them and saying, look, you guys, this is not an option. This is a given. We have to do this stuff. It's not. It's no longer a nice to have. Our trade quality of the guys that we've got in the paddock has significantly reduced. We don't have that skill set anymore. So we have to find ways of being able to point them to the problem and show them what to do. We don't have that ability now. Like, in my day, and I'm not blowing my own trumpet, but in my day, I didn't have a manual, I didn't have a computer, didn't have any of that stuff. If I couldn't figure out what was wrong, nothing got fixed. But that isn't part of our training anymore. They teach them how to remove parts, put them back on, do it quickly, send the machine back to work, because we've got massive drivers for production time and stuff like that. So to me, this is, and I think in summary, this is no longer a nice to have, it's a must have.
Yeah. All right, time, Dane. We've got time. Sorry,
Awesome.
mate.
All right. No, it's fine. Thanks very much, Steve, for your time. Appreciate your input and jumping online so quickly. I think we'll have to do a part 2 of this at some stage. So Thank you very much.
You're welcome.
All right. Thanks, everyone. Catch you later.